I'm Gardner. If this is your first time here, maybe you're trying to get into InfoSec, this talk is probably a good one. Nmap was one of the first tools I got encountered with. It's a pretty common tool when you're beginning because it's easy to use, easy to understand. It's a simple port scanner. So you can kind of just say Nmap and whatever you want to scan, let it go. We'll get into that. Also, if you were here to listen to the National Maternity Action Plan, I'm sorry, but hopefully you'll find something interesting anyway. So, to begin with, Nmap's importance. It's used to collect information on systems. It's usually a first step in any kind of penetration test, and it's very versatile. It does port scans and even do version OS detection, and later on we will get into some scripts that it can use. It's mainly meant to be used from the command line. There's a tool called Nmap. It's a graphical version of Nmap, but it's kind of shitty, and don't use it. That's a personal recommendation. Every option is available from the command line, as opposed to Nmap. If you're not comfortable with the command line, get used to it, because and you want to use Nmap, please get used to the command line, because this is the best way to use it. Like I said before, using Nmap is as simple as Nmap and then an address or a host name or an IP range. For input, you can do an IP address, a single IP address, like 192 blah blah 1, and all that info is up there. You can also do a file name, and if you have specific addresses that you don't want to type in one by one, just throw in a file name, and then Nmap will scan the file and do whatever you want it to do. It's very nice. Also, if you're of a certain malicious type or have some other reason to scan random IP addresses on the internet, I won't judge, but there is an option for that. You just give it an IR flag, and then the number of hosts you want to scan, and Nmap will keep track of all that. So on to some of its particular features, there's something called list scanning. List scanning is great for host discovery. If you go on Nmap's documentation page, it'll actually be under the host discovery page. It basically just calls up the router, asks who lives at, say, can everybody see that? Even in the back? No? I'm sorry. That's as big as I can blow it up. Basically, basically, all this is just a list of IP addresses and names of what devices live at those IP addresses from the network. There's no information, no packets sent to the actual devices themselves. It's just from the router to whatever scanning machine you use. Pinging a host, have you ever heard the term pinging some computer? There is a tool called Ping, and Nmap does use it. It's part of the ICMP protocol. It's nice sometimes to determine if a host is online or offline, but it's inaccurate. Some hosts just completely block them because they don't want to be found at all. And Nmap, you can specify it and tell Nmap not to ping anybody, so you're a little extra stealthy, but it might yield some kind of weird information. So always be careful when pinging with Nmap. Service fingerprinting. This is actually a really cool feature. I've had to do a lot more research on this into this particular presentation. And Nmap has this giant database of services that live on certain ports, like SSH on port 22 or HTTP on port 80. Common services that it expects to find when it sees that port 80 is open. And it'll send particularly crafted packets to these ports after it's already determined that they're open. And depending on how the response is set, let's say it's an FTP banner, and Nmap recognizes that, it will tell you with near 100% certainty that is FTP living at that port, because it's possible to, say, put FTP at a different port, like port 80, if you want. It does this by, again, analyzing what the response from the server is, like TCP buffer size, which is kind of the max size that TCP packet can be at. Some OSs even have different buffer sizes. Here's where, what is that? Here's where also OS and service fingerprinting come in too. There's a -A flag, capital A, right up at the top. And it turns on a whole host of what Nmap calls advanced and aggressive services or fingerprinting techniques. That's why there's a capital A. So it does OS detection and service fingerprinting, like specified in the previous slide. It also does trace routing, which can be useful for if you're inside a network and you need to know what path it takes to a server. And it does script scanning, which is a very neat little flag that I will get into in a second. The only problem is if you're trying to be really stealthy, it has very heavy network usage. Do not use this flag. Be a little more specific with what you want to find, because literally tens of thousands of packets are sent at any time. You can try the TCP dump and analyze the packets sent from your Nmap machine and find that out on your own. So Nmap scripting, this is a really cool part of Nmap that isn't, unfortunately, is not commonly known. Nmap can do things like brute force FTP credentials or check to see if there's anonymous logins on graphical X servers and FTP servers. It can see if there are default passwords on certain ports. It's very cool, and the Nmap database has, the Nmap website has a lot of references to these scripts. You can find them at the bottom there. And for example, if you want to run one of these scripts, you just specify a -- script flag and then whatever script name you want. And for example, this is SMB OS discovery, and you can enumerate SMB data over a network just using Nmap. You don't need an external tool. There's also a script help flag in Nmap itself that if you don't know exactly what you're looking for, but you know the general idea, like you need something over HTTP, you can use regex to find a script name that might help you. And that is it. I didn't have